Okay, hi, we're here today. It's September 20th, 2023. We're here with Professor Chen of the Chemical Engineering Department of CCNY. And Xi, thank you very much for spending time with us and sharing with us some of your life experiences and something about your work. So tell us a little bit about your journey on how you got to here to be a professor here at CCNY.
Sure. So I was trained as a mechanical engineer when I was an undergrad. Actually, I got my undergrad from China, and then before I came to US, I like mechanical engineer, and then also during that time I'm pretty good at instrumentation. I was working on navigation during that time, and then after I came to US, I switched to material science. Nanomaterials for my PhD. During my PhD, I was working on ceramics, piezoelectric nanomaterials, and then after my PhD, I was a little bit tired about the stuff I was working on, and then I switched to biology.
Wow.
And then right now I'm back to engineering school again. So the reason why I came to CCNY is there's several reasons. So during my postdoc period at Columbia University, during that time I was in biology department, and then I would say we were really lucky. We discovered a new kinds of material. It's called we call it water responsive material. So the material can swell and shrink in response to humidity changes. It's just like our hair, right? So can swell and shrink when the humidity changes. And then the differently is the material is really powerful, right? So when they undergo this kind of shape changing, and then by using the material, right? So we invented the first engine that can directly convert the natural evaporation into mechanical motions. And so this is a brand new. We actually during that time there's a brand new renewable energy technique, right? So I want to keep working on that. And initially I was trying to start a company, get some VC fund, but unfortunately because the technique is too early, right? So it's a little bit. It's very challenging to get a VC fund at that early stage, and then also there are lots of fundamental questions we would like to answer during that time. So and then I was thinking maybe let's maybe figure out these kind of fundamental questions in the school, and then I was looking for kind of faculty positions actually everywhere, and then suddenly I noticed, right? So there's ASRC, CUNY Advanced Science Research Center, and then during that time the center is brand new and then has all of the equipment I have, and plus actually initially I was thinking I go to the center and then I have everything I need, so basically I can start my journey over there, and then I got an interview over there, and also during that time, there's an opportunity to affiliate with, one of the CCNY departments, right? So, and then I start to talk to Ilona and also other faculties in our department. And also, I'm so surprised that, actually this department also, the people has expertise that actually we need, right? So to develop our technique. And then, for example, for our technique, right? So there's especially the water responsive material. There are lots of questions related to fundamental interfacial phenomena, water material interactions, and also simulations, right? So, for example, in our department we have lots of people, right? So with expertise within this kind of area, I thought, and also this is kind of a perfect place for me, right? So to collaborate with different people to develop this technique. That's the initial reason. I was so very excited, right? So to join both the ASRC, Advanced Science Research Center, and Chemical Engineering Department during that time.
Okay, very interesting voyage. And so now you have a group with students. What generally are you guys studying at the moment?
So right now our group consists of 9 PhD students, 2 postdocs, and then they are from everywhere, chemistry department, physics department, as well as chemical engineering departments. And but the majority of the people comes from chemical engineering department. And then currently our group focuses on the fundamental mechanisms of water responsive material, right? So and also we also develop new kind of water responsive material. So over the past 6 years, we spent tons of energy on developing, understanding the fundamental mechanisms and also developing new materials. And then right now in my lab, right, so I would say 80% of students work on the fundamental understanding of water responsive phenomena, and then maybe 20% of them, right, so working on the material development and the scaling up effort.
Scaling up, not discovery of new materials, but scaling up.
Yes, scaling up the materials. And then, but in the end, right, so this is still our dream, right, so to scale them up, right, so and make a really new energy harvesting technique available to everyone.
Okay, and you said you have 11 students, and that's a fairly large group, yes? Right? So what type of interactions do you have within your group? Do they work very collaboratively?
It is actually, because the whole group, right, so the major theme is really about the water material interaction, water-water interaction, and then how can we use this kind of fundamental knowledge to develop new materials. And then many, I would say, students work very collaboratively, and then usually in our lab, right, so when the first student join the lab, right, so the senior student or postdoc will give the training, and then maybe hopefully during the first year, right, so the new student will have a co-first author or co-author paper during this kind of training process, and then maybe 2 years later, right, so once the student can handle more graduation equipment and also understand more about the fundamental science, right, so and then the student will start to lead their own projects.
Okay. And how have the students found working at CCNY and life in New York City and trying to manage all of that?
So I would say it is tough for most of the PhD. So PhD is not easy basically, and then especially in New York. So actually I think as a faculty and also as our department, right, so we are trying to provide necessary support for all of the PhDs, right, so for them to achieve their career goal. And then in general, students still have a decent work-life balance, and but in the end, right, so it really depends on what's the dream of the student, and then what's the goal of the students, right? So basically, it will be a little bit different from student to students, right? So in the end, it's really depending on the individual ones, right? So what's their career goal after the PhD?
So your students that have already graduated, what type of positions have they found?
I have one postdoc, 3 PhD students already finished or graduate from my lab, right? So the postdoc right now she's assistant professor at Yonsei University. It's a top 3 university in Korea, and then she's Korean, and then she preferred to go back to Korean. And my first PhD is from physics department, and right now he is actually my first PhD is a chemistry student from the graduate center, and then actually she within 3 years she published first author Nature material paper, and then she graduated pretty fast, and right after the graduation she got a job in, I think, Lauder, the company, and then I think recently last year she moved to another company, BioAdvisor, and then my second student, actually they joined pretty similar time. My second student is from physics department, and after the PhD he went to Stanford as a postdoc. Right now he's a postdoc at Stanford. Okay. And my first chemical engineering student is Alan Liu. So right now he works with IBM and Micronics Research Center. So there's a pretty big research center between IBM and Micronics, and he's working on semiconductor research over there right now.
So the background that they get from working in your lab seems to be very amenable to being applied to different areas in industry.
Yeah, but I think as a PhD, right, so we spend lots of time working on fundamental science, right? Yeah. So basically, in the right, I think it doesn't matter what's the field, what people working on, right? So basically, the company need people who can solve the problem, right? So actually, yes. The PhD is really how to say the right kind of person, right? So they need to solve their problems, and also during the training, right? So we also try to emphasize the problem solving skill over the 5 years, and hopefully, when they approaching graduation, right? So they can. Yeah, they can develop their own vision.
Mm-hmm. And are there any people in your group that are leaning towards an academic future? Or you think most of them want to?
Currently in my group, 50% they want to stay in academia, 50% they want to go to the company.
Okay, well that's quite a bit factor.
And so it's not, again, right, so academia is not easy.
No. And
it will take a long time, and sometimes depends on how lucky you are. So
they generally need to do postdoc also.
Yes, and then practically maybe in the right, so I would say maybe 80-70% people will eventually go to industry, and yes, 30%, 20 to 30 may stay in academia.
Okay, good. So if I were a young student, a graduate student, or an undergraduate, and I was thinking of possibly coming to CCNY, to the chemical engineering department, and maybe I was even thinking of potentially working with you for my PhD, what advice would you like to give me?
So I think, so first of all, the PhD journey is not easy, right? So it's at least 5 years, and then how to say, we will suffer lots of student will suffer lots of work-life balance, and then the pay rate is also not as good as the company. So basically, I think the first advice is that the student is better to how to say understand more about what we are doing, and then see whether he or she really likes it or not. If someone who don't like what we are doing, right? So basically, or don't have the same vision or same goal with us, right? So it will be very tough, right? So during the PhD.
So it's a lot of what you're saying, paraphrasing. It's a lot of effort required, and the payback, which is often 40 years of a very interesting career, takes 5 years or so to realize, to get to that payback.
Yes.
So there's some sacrifice.
Yes, and yeah, exactly. And
Yeah, most of us have gone through that period.
yeah, that's true.
And I think most of us feel like it was well worth it because we're trained in a way that, we wouldn't have been. And we can do things that we wouldn't have been able to do if we didn't have that kind of training.
Right, I agree. And then I also think, right, so it doesn't matter what the research is about.
That's right.
And then it's all about what kind of problem solving skill students learn during the PhD.
Yeah, exactly. That's a really good point.
And then, to me, I also hope, right, so my students can have their own vision when they graduate. They can decide, right, so which is good, which is not.
Okay. Okay.
Yes.
Well, that's very good, Ji. Thank you for joining us today. Appreciate it. And I hope some students will see this and feel motivated.
Thank you. Thank you.
Okay.
Really, really appreciate it.